Good morning dear students, this is Bonani Porokasto. I welcome you all to today's video. Here we are doing the chapter Continuity and Differentiability. Here we are starting exponential and logarithmic functions. So the exponential function with positive base b greater than 1 is the function y equal to fx equal to b to the power x. So whenever we will say exponential function, it should come to our mind that the function is of this kind, fx equal to b to the power x and b is greater than 1. This is called exponential function. Now the next point is exponential function with base 10 is called the common exponential function. Whenever the base is 10, then it is called the common exponential function. That means in place of b, if we have 10. Now what is e? 1 plus 1 by 1 factorial plus 1 by 2 factorial plus dot dot is a number between 2 and 3 and is denoted by e. So whenever we will say e, we have to remember that the value of e is this: 1 plus 1 by 1 factorial plus 1 by 2 factorial plus dot dot dot. The exponential function y equal to e to the power x is called natural exponential function. So whenever the exponential function is given in this way, e to the power x is called natural exponential function. What is logarithm? So logarithm of a to base b is denoted by log a base b. So logarithm of a to base b we will write in this way, and we will read it as log a base b. Log a base b is equal to x if b to the power x is equal to a. So let b greater than 1 be a real number, then logarithm of a to base b is x if b to the power x is equal to a. Now here b should be greater than 1. We have to remember that b is greater than 1, then only log a base b is equal to x if and only if b to the power x is equal to a. Now we will take some examples. So whenever we will write 2 cube is equal to 8, we can write it as log 8 base 2 is equal to 3. Here log x denotes the logarithm function to base e. So whenever we will do questions taking log x, we have to remember that the base of the log x is e. Here log x denotes the logarithmic function to base e. We know 5 cube is equal to 125. Here we can write log 125 base 5 is equal to 3. Here some formulas are there. Log p base a is equal to log p base b by log a base b. Log pq base b is equal to log p base b plus log q base b. So whenever here multiplication is given, we can write it as addition. Log x by y base b is equal to log x base b minus log y base b. So whenever division is there, we have to write it as subtraction. Log p square base b can be written as 2 log p base b. Log p square base b can be written as log p into p base b. Now it can be written as log p base b plus log p base b. We know whenever multiplication is given, we can write it as addition. Now if we add these two, we will get 2 log p base b. So from here we can say log p square base b is equal to 2 log p base b. Log p to the power n base b is equal to n log p base b. Differentiation of e to the power x with respect to x is e to the power x. Differentiation of log x with respect to x is 1 by x, and differentiation of a to the power x with respect to x is a to the power x log a base e. Question number 3 of example 29. Here it is given that cos inverse e to the power x, we have to differentiate this with respect to x. So first of all we have to write ddx of cos inverse e to the power x. Now we know ddx of cos inverse x is equal to minus 1 by root over 1 minus x squared. So first of all we will apply the formula of cos inverse x. So it will be minus 1 by root over 1 minus e to the power x whole square, because in place of x here we have e to the power x. Now we have to again differentiate e to the power x. Differentiation of e to the power x with respect to x is e to the power x. So our answer is minus e to the power x by root over 1 minus e to the power 2x. Question number 3 of exercise 5.4. Here we have to differentiate e to the power x cube with respect to x. So first of all we will apply the formula of e to the power x. So we will consider x cube as x. ddx of e to the power x is e to the power x. So here we have to write e to the power x cube. Now we have to differentiate x cube. Differentiation of x cube with respect to x is 3x square. So our answer is 3x square e to the power x cube. Question number 4 is sine tan inverse e to the power minus x. We have to differentiate this with respect to x. So first of all we have to write ddx of sine tan inverse e to the power minus x. Now first of all we will apply the formula of ddx of sine x. In place of x we have tan inverse e to the power minus x. ddx of sine x is cos x. So cos tan inverse e to the power minus x. Now we have to again differentiate tan inverse e to the power minus x with respect to x. So tan inverse e to the power minus x, here we have to use the formula ddx of tan inverse x. ddx of tan inverse x is 1 by 1 plus x square. So here we will write 1 by 1 plus e to the power minus x whole square, because in place of x we have e to the power minus x. Now we have to again differentiate e to the power minus x. Now we have to differentiate e to the power minus x with respect to x. Here we will apply the formula ddx of e to the power x. So ddx of e to the power x is e to the power x. So in place of x we have minus x here. ddx of e to the power minus x is e to the power minus x, and since we have minus x in place of x, we have to again differentiate minus x. So differentiation of minus x with respect to x is minus 1. Now the answer is minus e to the power minus x cos tan inverse e to the power minus x by 1 plus e to the power minus twice x. Question number 6. The question number 6, here it is given e to the power x plus e to the power x square plus e to the power x cube plus e to the power x to the power 4 plus e to the power x to the power 5. Now we have to differentiate this. So here we will differentiate e to the power x with respect to x. So the answer is e to the power x. Now we have to differentiate e to the power x square with respect to x. So first of all we will write e to the power x square. Again we have to differentiate x square. E to the power x cube ddx of x cube. E to the power x to the power 4 ddx of x to the power 4. E to the power x to the power 5 ddx of x to the power 5. Now ddx of x square means 2x. ddx of x cube means 3x square. ddx of x to the power 4 means 4x cube. ddx of x to the power 5 means 5x to the power 4. So this is our answer. Question number 7, here it is given that root over e to the power root over x. So here we have to differentiate this with respect to x. ddx of root over e to the power root over x. First of all we will consider e to the power root over x is x. So here it is given, suppose ddx of root over x. The formula of ddx of root over x is 1 by 2 root over x. So here we will write 1 by 2 root over e to the power root over x. Now we have to again differentiate e to the power root over x. Here we will use the formula of ddx of e to the power x, and in place of x we have root over x. ddx of e to the power x is e to the power x And since we have root over x in place of x, we have to again differentiate root over x. ddx of root over x is 1 by 2 root over x. So our answer is e to the power root over x by 4 root over x into root over e to the power root over x. So in this question, first of all, we have applied the formula of ddx of root over x. In place of x, we have e to the power root over x. Since we have e to the power root over x in place of x, we have to again differentiate e to the power root over x. Now here we will apply the formula ddx of e to the power x. So here we have root over x in place of x. Since we have root over x in place of x, we have to again differentiate root over x. Question number 8, log x. We have to differentiate this with respect to x. So ddx of log x. First of all, we have to apply the formula of ddx of log x. We will consider this log x as x. So it will become 1 by log x, as the formula is ddx of log x is 1 by x. Since we have log x in place of x, we have to again differentiate log x. The formula is 1 by x, so our answer is 1 by x log x. Question number 9 is cos x by log x. We have to differentiate this with respect to x. That means we have to find ddx of cos x by log x. So first of all, here we will apply the formula of ddx of u by v. Log x whole square is not equal to log square x. Whenever we will write log x whole square, we have to write it in this way only. Question number 10, cos log x plus e to the power x. So we have to differentiate this with respect to x. ddx of cos within bracket log x plus e to the power x. So first of all, we will apply the formula ddx of cos x. In place of x, we have log x plus e to the power x. ddx of cos x is equal to minus sin x. So we will write minus sin log x plus e to the power x. So since we have log x plus e to the power x in place of x, we have to again differentiate log x plus e to the power x. Now differentiation of log x is 1 by x and differentiation of e to the power x is e to the power x. So our answer is minus 1 by x plus e to the power x sin log x plus e to the power x.